Now we are going to study about the contraction of the muscle. So this contraction of the muscle is usually called by three different names. That is the muscle contraction, sliding filament theory, or cross bridge cycling theory. All of these three are a similar name only. They can ask you in any different name. So coming to muscle contraction, so what is the first step? Already we have seen that now the actin myosin side, everything is exposed, all of them are ready to bind, but still we need help of many people. And what are those people? The first one is among them is ATP. The first one among them is ATP. So what has to add to the ATP? The ATP goes in for hydrolysis. So the first step here is ATP hydrolysis. So whenever ATP goes in for hydrolysis, it releases high energy phosphate bonds. Because of this, what is going to happen? Now the actin and myosin are going to get attached to each other. So the second step is it is going to get attached to attachment. Attachment is the second step. And in this attachment, usually it is attached perpendicularly. That's why we have written it is attached at 90 degrees. So once it is attached, what it is going to do is, now actin is there. The myosin is not going to move because the base myosin will be like this. Only the globular heads are going to move. This is the globular head. This white piece is the globular head. So what will happen? They will move like a rowboat. Like we are rowing the boat. It will move. Just pull the actin towards the next side. So what will happen? They will come closer, and there is bending of this globular head from 90 degree. It will go for a 45 degree. This movement is called as the power stroke. So both the side is pulling. So what will happen? There will be a muscle contraction. This third event is called as the power stroke. This third event is called as the power stroke. From 90 degree, it goes to 45 degree. Then comes the fourth part. Fourth part, again we need an ATP. Initially we were needing an ATP here, and again we need an ATP. Why is this ATP needed again? Because attachment is done, but now we have to detach it, because I don't want my muscle to keep it contracted. Once it has done the action, I want it to relax. So fourth step is nothing but a detachment. So detachment has to happen. So once detachment is happening, for that also ATP is required. So there is one important MCQ here. What happens in case of rigor mortis? In rigor mortis, what is rigor mortis? Whenever the person goes in for a death, after the death, there is severe contraction of the muscle. Because of this severe contraction, what is happening? This ATP, first step we have ATP, because already in a living state, the person will have stored ATP. So what will happen? This first step will happen, ATP hydrolysis will happen, attachment will happen, it will go for a power stroke. But since the person is dead, there is no new ATP generation. If there is no new ATP generation, which step will not happen? The fourth step, or the detachment, is not going to happen. If detachment is not going to happen, what will happen? The muscle will go for a severe contraction and there is no relaxation. This state is called as a rigor mortis. So this can be asked in the questions, like what is not happening? Here ATP is not available and the detachment process is not happening in muscle contraction theory. Now coming to the other set of protein, that is the anchoring proteins. What is this anchoring proteins? Anchoring proteins, as the name suggests, they are going to anchor and hold the muscle. In this, one important protein is there, that is the titin. There are several proteins, but one we have to keep it in mind, that is the titin. It is important. So as you can see here, what is the central line here? The central line we studied in the structure, it is M line. What is this line here? It is Z line. So where is titin? Titin is attaching the M line to that Z line. So it is basically like it is holding the both ends of the proteins, like the protein is holding the entire muscle. So it connects, this connects M line to Z line. This is the, and it is a very large protein. Why this protein has to be there? What happens is, it is like a coiled wire. So whenever the muscle is being stretched, first uncoiling will happen. So the muscle is stretched, but whenever the muscle tries to overstretch, what it will do? It will anchor and hold it. It will prevent the overstretch. Why we don't want overstretch? If overstretch is happening, the muscle will go for some kind of stretching and its functionality will be affected. And in heart, this will go for a dilated cardiomyopathy. If the heart is being overstretched, it is going to go for dilation. and dilation there is no use, and it will create a severe cardiac disease which is called as dilated cardiomyopathy. So they can ask what is the protein which is defected in dilated cardiomyopathy, and they can give you various options. Among those, we are going to choose titin because it is a group of disease which is included in titinopathies. So this titin is preventing the overstretch. That's why this anchoring protein is very, very important. So this is all about the skeletal muscle.